Going to see about geometric transformations, 3D geometric transformation. First one is translation. All the transformations we are going to see in 3D transformation is very similar to 2D transformations. So first learn about 2D transformation and then check this video. So the formula is same, x dash equal to x plus t. We know x in 3D point is represented x, y, z, and it can be converted into homogeneous x comma y comma z comma 1. On representing it as matrix, we can say it as x, y, z 1, and the translation vector tx, ty, tz. So in order to represent the inhomogeneous into homogeneous, we are going to use the formula I t into x, where I is the identity matrix. So 1 0 0 0 1 0 0 0 1, and the translation vector tx, ty, tz. We have to append the 0 vector and add with 1. Okay, the same translation. Translation is nothing but moving the same object to another location, or moving the same point to another location. Okay, we are just moving, the length, width, angle, everything will be same. Next is rotation plus translation. It is also known as Euclidean transformation or rigid body motion. The matrix is also same. We know cos theta, rotation matrix is cos theta minus sin theta and cos theta. So we'll add the translation, right? So tx, ty, tz. So I'm going to add 0 and 0 here. So this is the rotation about z axis. Okay. So if you want to perform rotation about y axis, then it will be cos theta minus sin theta. Okay. Just give me a minute. Sin theta and cos theta. Okay, so 0 0 0 0 1, and then tx, ty, tz will be added. So similarly, Rx will have the cos theta, sin theta in the lower dimensions. Okay, so this is about rotation. And if you want to perform rotation about the camera center, if you want to consider the camera center as the origin, then we are going to represent the point as C. So the object may be anywhere. So let us assume the coordinate object is this, and if you want, the camera is here, and based on this camera center, if I want to perform rotation, means I have to move this point to this point, right? So the x and y should become the camera center. So what I'm doing is I'm subtracting the x with the center value. So x minus c, which makes this x to the center of the camera. Then r of x minus c will become rx minus rc. Then scaled rotation, the same formula, SRT. S represents scaling. Scaling means the size will be enlarged. If the size is small, we can enlarge it or we can shrink it. So the how much size we should scale is represented with the value R. So this representation is inhomogeneous representation. This is homogeneous representation, similar to the previous one. And then affine. Previously we know affine is 0 0 0 1 0 2 1 0 1 1 1 2. This is for 2D affine transformation. Here we are adding one more row and one more column. Same here, it represents the translation, this represents the rotation, the diagonal represents scaling, and the off diagonal represents shading. Everything is confined into a single matrix. Again, the projective, the equation is same for 2D, same as 2D. X bar dash equal to h bar x bar, and again the matrix is same, h naught naught. It is represented, right? 4 cross 4, h naught naught, h naught 1, h naught 2, h naught 3, H10, H11, H12, H13, H20, H21, H22, H23, H30, H31, H32, and H33. Right? So here also we can perform the 5 transformations which was discussed in 2D, right? So translation, scaling, rotation, shearing, and perspective. Here everything will be 3 cross 3. Now it is converted into 4 cross 4. So similar to the tx and ty, here will be tx, ty, tz, and xx, xy, xz. And as I said, cos theta, sin theta. So the same. This represents the normal one represents z axis. If I want to perform y axis rotation means cos theta minus sin theta cos theta will be there. All the zeros will be moved there. And if I want to perform x axis rotation, cos theta minus sin theta cos theta 0 0 0 1 will be moved here. So shear x, shear y, and shear z representation. Perspective A, B, C, D, E, F, G, H, and last one as usual 1. So similarly, the same H matrix is defined here. Now let us see the degree of freedom. Degree of freedom for translation is 3 because we are performing Tx, Ty, Tz, moving the object according to the point x, y, z. And here rotation, we perform the rotation based on z axis, x axis, y axis. So translation as well as rotation combines the Euclidean. So 3 plus 3 it is 6. In similarity, we'll perform only the scaling. So scaling can be the same. If I give the x value as 2, it will be scale the x, y as well as z to the same size. So 3, 6 plus 1, it is 7. And affine matrix we have seen, right? So it is uh, 3 cross 4. Every value represents something, right? So this represents translation, this represents rotation, scaling, and shearing is performed. So all the 12 values are considered. So the degree of freedom is 12. In case of projective, it is 4 cross 4 matrix. But you see, the last value will always be a 1. So like this 2D, okay, right? So in 2D also we haven't considered this value as a degree of freedom. So remaining values only considered. So here it is a 4 cross 4 matrix. Last element always be 1. So I am going to say the degree of freedom is 15. Thank you.